Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hello and welcome to Hardware to Save a Planet. I'm here with Rory Brogan, the CEO and founder of Torev Motors. Rory and his team have invented a more sustainable electric motor, and I've been excited to talk with him about this because electric motors are clearly such a key component of our energy transition. We'll need a lot of them to power all of the EVs and wind turbines we need to produce, among other things, to move away from fossil fuels. One knock-on effect of that is all the mining we'll need to do for the rare earth metals that go into those motors. That mining is expensive and harmful to the environment, and the geographically dependent nature of mining can put some serious supply chain risk on the production of motors. So a motor design that requires a reduced consumption of rare earth metals would be a big win, and that's what Rory and Torev are developing. To introduce Rory quickly, he started pursuing this idea of improving motor design 8 years ago while studying electrical engineering and mathematics in college. After graduating, he joined the venture capital world and got his MBA before founding Torev in 2022. I love that Rory had the courage as an undergraduate student to challenge such an established technology, and then the persistence to stick with it for 6 years before founding Torev. I'm looking forward to hearing more of that story. So Rory, thanks a lot for being on the show.
Yeah, Dylan, I very, very much appreciate it. Thank you so much for having me.
So I am curious to hear that story and how this all played out. What was going on 8 years ago that got you thinking you could improve on the electric motor? And I just looked this up, and the electric motor was invented almost 200 years ago, right? So this has been around for a while.
It's a very old and rapidly evolving technology, which is something that's very exciting to be part of. The real story kind of began way longer ago. I've always been fascinated with how things move, especially like cars, how we can make a vehicle go down the road and how we can do that really well. I never really fell into the mechanical side of things, really, but I was always more intrigued with kind of the electrical, especially magnetism. Just growing up, I always found it fascinating. And so I kind of gravitated into that world of electrical engineering. And right around 2015, 2016, you saw Tesla starting to make a lot of headlines. You saw a lot of conversations going on about electrification and are electric vehicles really the future? What does transportation look like 10, 20, 30 years from now? And that just kind of rang true. And I was in a electric motors and generators power class in my undergrad. And as an independent research challenge myself, whatever you might want to call it, started looking at the world of electric motors and doing my best to understand what was the cutting edge at the time, and really hoping to find something that was very fundamentally different from what had already been done. As you mentioned, this is a very old, very well-established technology. And there's some certain advantages that go with that, also some drawbacks in terms of the speed of innovation and then people kind of being used to looking at things through the same lens over and over. And so I was very, very hopeful to get the opportunity to explore something really fundamentally different. And it kind of led me down this rabbit hole. I've actually got right next to me here, this inventor's log of mine that has, I think, 50 plus iterations of just motor drawing after motor drawing. And eventually each one gets this big red X through it. Because I found one thing or another that just wasn't going to work out. And over the course of probably a year and a half of going down that path, I ultimately had this realization. And at the time I thought I had invented the axial flux motor. I got really excited. There's a page in that book. I even signed the bottom of the page, dated thinking I was onto this really new exciting thing. Realized I was beaten to that design by one Michael Faraday back in the mid 1800s. So I had a quick kick to my engineering ego on that one. But over the course of the design process I had employed, I did come across this or came up with, I should say, this very novel type of electric motor. And it's the motor that Torev pioneers today. We refer to as a double axial flux motor. And we really sell it as the next generation of electric motor. You start looking at the world of motors today, as you mentioned in the intro here, and there are some serious challenges we face. By the time it's 2030, we're looking at electric motor sales of billions of units per year. And the geographical concentration, the high consumption of rare earth metals, all of these things are compounding right now at a time when we really need to find efficient solutions that are allowing us to reduce this consumption. And our architecture of motor is just very, very well attuned to meeting that need.
And was that what you were pursuing back as a student, looking through all these, looking at all these different ways to what was driving you? What were you trying to achieve?
It was engineering for engineering's sake. Honestly, it was really a pure research passion project. I had absolutely no idea what was going to come out of it at the time. There wasn't a specific challenge. I wasn't. It's funny. I give entrepreneurs this advice, which is find a problem and solve it, and move from there. Right? Mine was kind of the opposite story, which was I just started exploring a technology, and really just as a passion project. I really at the time I had no idea where this was going to go. In fact, it took me until business school to really start realizing the advantages that we have from an economic perspective. I had an idea about the performance and the efficiency just from my engineering days, and the differentiation alone was enough to go to my professors at the time and just say, hey, I had this new idea. Have you seen something like it? Is this worth pursuing? And at the time, they all said, yeah, you absolutely should. You should go and look at patents and look at what it might take to run this thing. Also very fortunate that I had a close family friend of mine tell me point blank, look, you don't learn about running a business in engineering school. If you're really serious about getting this off the ground, it might be worth looking at the business world. And so that's where my initial experience came from, was kind of working from the very earliest stages on marrying that engineering mindset to the business mindset. And it's what's allowed us to make a lot of the progress we have today, is the understanding that the engineering is very, very important, but in order to actually get this to market, there has to be that business case. And so it has been a evolving process. It's not necessarily the same idea that I had way back when I was still a plucky young engineer looking at how can I try to make a new electric motor. And it's evolved into, okay, this is a reality. This is something that has real potential for potentially a very, very large, very well-established market, and something that is going to require a different mindset to really make a reality. And I'm very, very fortunate to have had a lot of the mentorship and the lessons learned over the years that has allowed me to kind of take the time, build up the idea, figure out how we need to get started, where we need to get started, and ultimately how to execute on those goals that we had set out.
When I first learned about what you're doing in Torev, what I picked up on was that the big advantage of your motor is the reduced use of rare earth metals. Is that the right way to characterize it? Is that kind of the main selling point?
It's one of them. In the world of electric motors, what we realized pretty quickly is that everyone and their mother is trying to create a motor with less rare earths or no rare earths or whatever percentage of rare earths you really want to put in there. And so it's certainly an advantage. It's a selling point when it comes to cost for us. But at the end of the day, we are, as any climate company is, right, we're subject to what we've been told is the Mr. Burns test, which is, this is great. You can reduce rare earths. You've got a good environmental impact. That's all wonderful. Why do I care? Why should I buy this thing? At the end of the day, you need to have that economic impact, right? And that is certainly helped by our reduction in rare earth metals. But where the real selling point comes from for this device is from what's referred to as a power density. You're able to get a lot of power from very, very small packaging. You're able to achieve this very unique, what we refer to as a dual operating mode, that just allows you a lot more control over the power going into your motor, what's ultimately coming out of your motor. And it just allows for a much easier way to extend battery life, to achieve a direct drive, to get gearboxes out of the way if you're looking at electric vehicles. There's a host of frankly, even right before this, we were talking to an aerospace company, and one of the things they were pointing out right off the bat was, hey, 2 coils, extra redundancy. And when you're starting to look at electrification of aviation, right, you start looking at failure in motors. You need to be able to provide that level of redundancy. And so it depends a lot, honestly, on who we're talking to, what the real advantage is. But the nice thing that we get to point to for all of them is that there is a more sustainable solution. It's just more of a cherry on top, as opposed to the full selling point of the device.
I know it's a very physical, sort of complex thing, but is it possible to describe how your invention works relative to sort of conventional, say, EV motors?
Yeah. So we work on the same fundamental principles as any other motor. The driving idea, no pun intended there, but the idea behind any electric motor is fairly simple. You have opposite and attracting magnetic fields, just like if you had like a permanent magnet, right? North pole attracts the south pole attracts the north poles repel, same with south poles repel. It's that exact same operation that allows any motor to work, including ours. What we have done, though, in our motor is integrated this very unique coil architecture. So in any electric motor, you have 2 very fundamental components. You have what's referred to as a stator, which is aptly the stationary part, and a rotor, the rotating part. And what we have adjusted is the stator. So the stationary component where you would normally attach the coils to your motor, what we have done is essentially broken a large single coil into 2 smaller coils. And doing my best to describe it here, just with my words and not with the actual component in front of me. What we have done essentially is wound these 2 coils in a way that you end up with a opposite and attracting magnetic field at all times. And so you're able to create this loop essentially of it's referred to as magnetic flux. It's just the magnetic field lines that you would normally see like emanating out from a drawing of a permanent magnet. We have found a way to really, really efficiently channel this magnetic flux, this magnetic energy in a way that we can maximize what we refer to as the active power generating volume. So maximize the volume of the motor that's really actively generating a magnetic field, as opposed to passively generating a magnetic field like a permanent magnet. Very, very similar. This is a technical term, but there's a shape in the world of electromagnetics called a toroid. It's just a donut with a wire basically threaded all the way around it. And the whole idea of this shape is that when you apply a current to the coil that's wrapped around it, you end up with a very, very tightly controlled magnetic field that lends itself to very, very high performance inductors or other circuit board components. And we've taken the same basic idea, that idea that you want a very well controlled magnetic field shape within your motor to achieve high efficiency. And we implement what's referred to as a semi-toroidal field, which just means it's not a perfectly wound donut with the wire around it. We only kind of get the top and the bottom. But it does lend itself to a very, very high efficiency motor design. Third party feedback on the motor itself is that we have very, very little leakage flux, which is just a loss type in electric motors, which refers to magnetic field that's not actually getting used in the power generation of the motor itself. We have very, very little of that, which is just a indication that this loop that we are creating works. And it does work very, very well. We've had several tests now that have demonstrated as much.
Which I guess would translate to more range per watt hour of battery or something like that in an EV.
Exactly.
Yeah.
Exactly. So if you look at the metrics like what Tesla uses to judge their motors by, what they realize in their vehicles is for every 2% motor efficiency gain, you see somewhere around a 5% boost to your vehicle's range. And so it's this asymmetric advantage. And so anything that we can do to increase your motor's efficiency, while of course being able to do it more sustainably, right? Historically speaking, if you're making a really, really high efficiency motor, you have to use a lot of rare earth based permanent magnets. And our ability to achieve equivalent performance to what currently exists on the market, but for such a significant drop in rare earth consumption is a very, very big feat and something that we're seeing a lot of traction for right now in the market.
Mm-hmm. Okay. So it's not so much that your efficiency is better than existing motors. It's that you're able to match existing kind of performance characteristics with the lower cost and a lower environmental impact through the rare earth metals. Yeah.
When you look at the efficiency of electric motors today, you're bordering 96 to 98% efficient. These are remarkably high performance motors. Incredible what we've been able to achieve in the motor field over, I guess that's the mid 1800s, right?
Mm-hmm.
But even just recently, what we've been able to achieve in some of these very, very power dense motors, ours included. But if you really start looking at the efficiency is kind of this thing where, hey, we've kind of run up on a wall. You have to take a step back and start thinking about, okay, what does the next generation of this look like, right? Again, kind of getting back to this idea that sure, we have very, very high performance motors on the market right now, but if these are all so heavily reliant on rare earth based permanent magnets, and especially with the speed that we need to maintain to achieve electrification by 2035 and the scale that if you think about we have to hit, we need new motors that are able to significantly reduce. And again, that's kind of where we come in. And we focus right now, at least on reduction for a very good reason, which is that right now, at least supply meets demand for rare earth metals and electric motors. So while there is certainly pressure to start moving away, there isn't this imminent, like heart pounding in your chest. We need to move tomorrow. This is the world. And there's some time that we have that we need to focus on reduction. And then ultimately meeting these manufacturers where they are, so they don't have to completely redo their supply chains. They don't have to move on to materials they're not familiar with. They can use a motor that they're very, very familiar with that's just better designed and allows us to make a real sustainable first step, as opposed to saying we need to throw everything out the door all at once. It's as much as I would love to see the whole industry turn all at once, it's a steady and gradual change. And certainly being able to make a difference right now is going to just cascade into a much, much better future as we approach that 2030 or 2035 deadline.
Mm-hmm. And just so I understand the rare earth metals part of it, is that the rare earth metals come into play on the motor in the rotor. Is that right? The permanent magnets is where we're using those metals today, and your design, yes, I guess, uses fewer magnets or smaller magnets. Is that the way to think about it?
Exactly.
Okay.
Exactly.
Okay.
So the rotor, and it can change, but for general purposes, the rotor of your motor holds the permanent magnets. Those magnets are based on rare earth metals. Think of it like a fridge magnet on steroids is essentially what these things are. But right now there's again, just a lot of focus, especially from a supply chain and economic perspective on how are we going to move away from them? How can we reduce our consumption? But also balancing that motor's performance that you're so used to seeing the benefits of in the process.
Mm-hmm. So you've talked about this a little bit. My assumption is that there's a ton of people looking at improving motor designs, and you're like, if you look at the sort of all of the money going into motor development, there must be, I know Tesla is investing in this, but there must be big established incumbents kind of investing a ton of R&D dollars into this. I'm curious, as a small early stage startup, what is it like kind of working in that context?
It's interesting. We have maybe a case in point here to people looking at this. We have yet to meet a customer who has really said, no, we don't want a new kind of electric motor. Everyone has said, yep, we're certainly interested. We love the possible benefits here. We want to explore it. And so these are folks ranging from other startups all the way up to some of the largest industrial and automotive players on the planet that we've been in conversations with. And so it's difficult at times to really balance where we need to be. And right, this is kind of part of getting back to this idea of, well, what's the market? Where do you start? How do you work on all of this? But at the end of the day, when we're really looking at how do we engage with these big players, how do we differentiate ourselves, a lot of it does come back to the technology. If you look at the amount of investment dollars people are putting into the motor world, and this is startups and existing players alike, what you see is this need for really, really novel technology as a means to successful deployment. There's a lot of people and a lot of motor technologies out there that focus on a specifically thermal solution. And certainly we need thermal solutions for these motors. No doubt about that. We need a good thermal system ourselves. But when you look at who the biggest players are becoming, especially in the world of axial flux motors, like where we're in, it's always something that is fairly fundamentally different. So you look at like Mercedes acquired a group called YASA out of the UK in 2021. Acquired it because it was probably the first real successful iteration of a axial flux motor in the automotive context. You look at a couple of other companies that are doing axial flux. It's called a reluctance motor, just a motor that has no permanent magnets in it. You look at printed circuit boards for your stators. You're seeing some very, very interesting technologies arising. But the one thing all of the most successful companies right now have in common is that it's something really different. And I think there's a very good reason for that, which is when you start considering yourself against the capabilities and the investment dollars that the really, really big legacy motor players, whether they're automotive or traditional motor manufacturers or tier one suppliers, whoever it is, if you're really just going head to head on the same kind of motor that they can create, the economies of scale just don't work. You're going against a behemoth, for lack of a better word here. And you really need to have something that is so technologically different and so compelling that it forces them basically to the table. Now, of course, you need to be very, very careful with that, right? This is where the IP comes in, is you need to be smart. You need to understand who you're working with. You need to understand what their motivations are. But at least right now, and this is especially true of the automotive world, and it's the reason one of the reasons that Mercedes made the acquisition of YASA, you start looking at brand differentiation and how it relates to your motor. Historically speaking, right, if you look at the automotive world especially, you have people with different motors. You have like BMW is not going to use a Mercedes motor. Ford doesn't want to use a GM motor. Within the world of electric vehicles, where everything is really so standardized, a electric motor looks awfully similar across vehicles. You start to realize that the motor becomes this kind of central component of what your brand can become. And if you're able to insource the motor technology that you want to see for the future of your vehicles, which is a trend that we're certainly seeing not only right now in the United States, but abroad as well, as this need to insource the technology to compete with folks like Tesla. And you see this as kind of an extension of your brand and a real definition of, hey, this is what we stand for. This is at a fundamental level what makes us different, right? That's where we really start to have the conversations with the bigger players of, okay, well, this is something that beyond just the performance is going to have implications for your branding, for the market that you're looking at. And that's kind of where the conversations start to center. But at the end of the day, when you're working with these big players, especially at a smaller level like us, you need to be smart but there's also a lot of potential out there right now, and we're finding that to be very true.
I was going to ask about that. So is that the kind of ultimate goal with Torev, is to sell your or license your motor to automotive OEMs?
Truthfully, I really come at it with the mindset of the world needs innovation like this, and we are very, very lucky to be able to play a part in it. The further along we can get the technology, regardless of what the outcome is, whether that's an acquisition, a license. I'm
Mm-hmm.
not necessarily a huge IPO fan, but that's my own personal experience with startups and IPOs. Um, where we really see ourselves is getting this as far as we can, working on building up those customer relationships, getting this to where it really is a sustainable, repeatable business model, right?
Mm-hmm. So does that look like Torev is then a motor manufacturer? You're building motors and supplying them to your customers?
Eventually. We
Mm-hmm.
are right now, we work with contract manufacturers. Sadly, building a factory is a very expensive piece of
Yeah.
work, very expensive.
Yeah.
So we're starting working with contract manufacturers right now. We certainly have conversations internally about where is the turning point of it makes more sense to manufacture these in-house, and it starts to make sense for that spend versus working right now with folks that already have the expertise and the capacity built in. But yes, for right now, we see ourselves as the supplier. The end manufacturer differs a little bit, but right
Sure.
now we like the control that we have over the product that we're able to offer.
Mm-hmm. From a business and commercialization standpoint, what do you think your biggest challenges are going to be? What keeps you up at night?
What doesn't keep me up at night? I think from a real production perspective, certainly being able to meet scalability targets is going to be one of the bigger challenges when you start to look at the world of especially electric motors, just with the sheer volume of motors that get created, right? A 10,000 unit order is a relatively small order in the scheme of electric motors. And it's a very, very large commitment to be able to create 10,000 motors in a year. And so certainly as we continue to scale up, there's going to be pressures and challenges and very, very tight deadlines that we're going to have to find a way to overcome to make sure that we're not presenting any risk from a supply chain perspective. And we're certainly taking the time, even from the very, very earliest stages of the business. We started working with supply chain partners to supply all of the truly critical components of this motor. But certainly the step between where we are now from a design and prototype kind of stage and moving into a real scalable commercial product, there's certainly going to be growing pains that we're going to face. And those are the challenges at the end of the day that I really focus on and think about how are we going to overcome that.
Mm-hmm.
Just because it's a challenge we're going to face no matter what.
So that's the challenge of getting from one to many, being able to produce many units. What have been the big challenges of getting from kind of those notebook sketches that you started with 8 years ago to your working units today?
Creating the motor itself
Mm-hmm.
has been the single biggest milestone that we've hit so far, just from a tech de-risking, from a product validation perspective. The fact that we have made a motor that works is an immense step. I've talked to motor startups before that have raised millions of dollars and never actually created a truly viable working prototype of their motor. And so this is a really fundamental differentiator for us, is having this technology now. Going from a notebook sketch to a real physical product was no small jump. That is, especially in the world of motors, right? It's not like you can buy a lot of off the shelf components for this stuff. You need to find a lot of times folks that have expertise in it. You need to find people that can put it together. You need to find any number of components and how it all fits together and be able to assemble and be able to test it and have all the equipment. Um, no small feat on that one. We are very, very lucky in the motor world, at least, that with the rapid rise of electrification and especially electric vehicles, there's been this, not side industry, but this kind of pop-up industry that's occurred of folks that can focus on specifically early stage motor design, prototyping, testing, stuff like that, that we were able to tap into. And we found a group that we still work with to this day that has expertise in early stage electric motor design, prototyping, testing, even early stage commercialization capacity. But certainly sourcing that group and finding a group that can do it half cost effectively. The first time my jaw ever hit the floor in this business, just from a price perspective, I think we didn't even have $50,000 in the bank, and someone gave us a quote, say, yeah, we can do all this design for you. It's going to cost you 300 grand. And it was just like, whoa, this is a very different world. We got very, very lucky that we found a group that was willing to kind of space things out, do it project by project, not charge us an arm and a leg, and allow us to survive through the very, very earliest stages of the business while still being able to demonstrate technical milestones and ultimately creating the actual physical prototype. That said, just as the caveat there, for any hard tech company, grant funding. Find a way to get that. State, federal, doesn't matter. That I cannot begin to tell you the difference that made being able to support the development of this technology.
Why is that? Why is grant funding important over other funding sources? Non-dilutive, or what's the
non-dilutive? Non-dilutive is important, but it also, at least at the state, I imagine this is true for all levels, but at least at the smaller state level that we have won, it's not a rigorous roadmap that you have to establish for things, but it helps to really align and just make you think about what are the real steps that we need to take to make this a reality, right? There's a difference between we won 75, that are now 115, but at the time $75,000 in grant funding through the state of Virginia. And we had the same thing, an angel check from a SAFE for $75,000. It kind of helped out there. But when you're looking at the impact of those funds, having something that is really set up that says, we are using these funds for this specific reason is just a very, very good habit to get into in the first place. But especially for an early stage business, is really good for aligning your thoughts and helping you think about what are the real steps that we have to pursue to make this thing. And we got the funding. It's quite literally what paid for the prototype behind us was that funding. But it was on top of being non-dilutive. It's something that is really good at helping you think about from a tech and a milestone perspective. How are you really going to use these? What are the different costs that go into it, right? And there's things you don't think about that are going to be there. And there's also things you're going to budget for that aren't going to be as much as you thought. And it's just a really good way to learn about your product and what it takes to build this thing, but also set yourself up in the future with a much more refined vision of, okay, now this is what it actually takes.
I'm also curious about this decision you made, as I understand it, outsource a lot of the prototype design and development to a third-party firm with expertise in that area. Did you consider that versus hiring experts in-house? And how did you make that decision? And do you think that translates to advice for other hard tech companies?
I think so. I think that I'm a very, very big fan of, if you don't know how to do something, find someone who does. And it's not just the engineering side, but it's also on like the legal side, the accounting side, stuff like that. Focus on what you're really good at. On my side, it was business development. It's fundraising. It's stuff like that. And so on the engineering side, I had to find someone who is going to be able to help us get a real prototype built. At the same time, when you start looking at bringing on full-time hires, the single most expensive thing you're going to do, regardless of the stage of the company, is going to be bringing on people. It's especially at the early stage, it's going to cost you equity. It's going to cost you cash. It's a big commitment to bring someone on full time. And at least at the early stage, being able to find basically a technical consulting group that really has specific expertise in, we build motors. We've been doing this for 25 years. We've seen all kinds of motors. We've built them for automotive and defense and appliances and whatever else it might be. Finding folks that have that expertise built in, it saves you a lot of time going around saying, well, what do we actually need to build? They're able to provide some guidance on, hey, this is where we usually see projects start. This is where we see the process evolving. This is what it usually costs. It might be more expensive if you were to really apply them like full time with the consulting fees, but just from at least at the early stage where we are, from a project by project basis, which I think is where a lot of hard tech startups start out, it made a really, really big difference to us. And at the end of the day, actually saved us a lot of money in the process. And so I think that as much as you can, if you can, again, just find folks that really have that expertise, you go that direction.
Yeah. No, it makes a lot of sense to me. And that's, you also have all of the time it takes to find the right people and to build a team and to have that team learn how to work together and all of that. If you're trying to do it in-house with by finding a firm like you did, you sort of hit the ground running with that. That makes a lot of sense. Thinking about the future of Torev, what's your vision? What kind of impact to the climate do you think the company can have, to the industry? What does that look like?
Starting off with the climate, this is something that a lot of people don't think about. There are motors all around us. Your ceiling fan, HVAC units, industrial compressors, smokestacks. It was, of course, EVs, right, being a big one. But if you think about where energy consumption comes from, electric motors alone, based on at least stats from 2022, absorb 28% of global power consumption.
Well,
the actual systems they run consume 40%. And so you think about just the scale that you start talking about at a global level. This is, I think I saw it was like 15 petawatts of energy. I think it was 15 followed by something like 10 zeros after that. It is a massive, massive number. And to think that 40% of energy consumption is coming from electric motors and their systems, the sheer impact that even an efficiency, a percent efficiency gain has on that whole system is simply remarkable. And we start looking at how we're going to electrify, how are we really going to extend our electrical grids to meet the challenges posed by charging, to meet the challenges posed by everything running on electricity in the very, very near future. Motors play an undeniable role in that. And our requirement to find ways to produce the highest efficiency motors possible at a reasonable cost is of paramount importance. And it kind of all gets back to this idea of, you have this massive, massive demand. You have this high power consumption industry. And you start to look at the supply chain that goes into that industry. And again, you realize very, very quickly that it is geographically concentrated with nations that are not always particularly friendly to the United States. So that represents not only a supply chain risk, but a national security risk in kind of the second place here. And you start realizing that if we're really going to achieve these goals of electrification by 2035, motors need to take a very serious precedence. And we see a lot of articles coming out about batteries, about EVs. Very rarely do you see anything about the need of motors, despite this outsized role they play in all of our daily lives. And so when you look at the the climate impact that we can have just on the efficiency of motors alone, it's staggeringly high. Now you start to look at the rare earths consumed, right? As you mentioned at the beginning, rare earth mining and processing is a environmentally taxing exercise, to put it nicely. This is the Harvard International Review. They released an article back in 2021, putting the ratio of processed rare earth metals produced to radioactive toxic waste generated of 1 ton of rare earths to 2,000 tons of radioactive toxic waste.
What?
And again, seriously,
Wow.
seriously, 2,000 to 1.
Yeah.
And you start to think about the environmental implications, the scale of the disaster that could await us if we're not able to really start making a meaningful change on this supply chain. It is urgent, doesn't begin to describe it. The need to begin moving away and toward more sustainable solutions. And again, we're very, very fortunate to be able to play a part in that. From a real step change within the industry, we were at a showcase. It's the Electric and Hybrid Vehicle Battery Showcase in Novi, Michigan this last September. And I think we were having a conversation with an engineering manager for a very, very large tier 1 supplier that put it best, which is that the second someone solves the cost problem of axial flux motors, it's all over. Everything follows that path. People understand the benefits of axial flux. They want the efficiency. They want the improved power density. They want the performance that it affords. The problem historically is that they're just very, very expensive motors. It's very complex to manufacture. There's a lot of rare earth consumption involved. Where what we're creating, which is something that's just so much more modular, can reduce that rare earth consumption by so much. We're able to really offer a cost-effective solution. And so you start looking at the market that we're able to target, and it's not limited to automotive. We look at industrial, look at marine, we look at aerospace. We look at all of these different markets, and we really see the opportunity to create a fundamentally disruptive technology that brings, really for the first time here, the benefits of axial flux motors at a commercially affordable level to the masses. It allows us to make this, or help us make this massive transition that we need to make.
Cool. That's super helpful to frame it that way. Okay, cool. I have 3 last questions for you that I ask everybody. How optimistic or pessimistic are you about the future of the planet, and why?
I would say I think I'm optimistic. I think that it's a very large task that's ahead of us. And there's no doubt about that. And there are going to be challenges, and there's going to be problems that we haven't even foreseen yet that are going to arise just on our path to get there. Overall, I think that you really are seeing a generational shift. I think that folks who were maybe originally not like, oh, climate change is happening or not, I think people are starting to actually feel the effects of how the climate is changing. I think that, right, you have these younger generations that are growing up with climate change on the top of their minds and seeing this as a real serious problem. And I think that you are going to see a lot more innovation. We're very, very fortunate to participate in 2 accelerators, with startups specifically focused on the sustainability and climate crisis. And some of these, we're building new electric motors. We're lucky that we've got the traction that we do. Some of these ideas are remarkable, just ideas I never thought I would ever hear about. So I think that certainly it's a big challenge, but the level of innovation, the brain power that is being applied to these problems, I think that I'm optimistic. I think that we will be able to get there. I think it's going to be a challenge. I don't think it's going to be an easy path, but I think that we'll get there.
That's a good segue to the next question, which is, who is another company or individual doing something to address climate change that's inspiring you?
Yeah. There's very lucky to have gone through an accelerator with this guy. His name is Seth Terry out of Denver, Colorado. He runs a company called New Day Hydrogen. He's much more humble about how he describes it. I say he's putting basically a oil derrick at every gas station. He's found this remarkable way to pull hydrogen out of the atmosphere, basically at a gas station, and allow you to create enough hydrogen to fill up like a semi truck or something like that. And so you start looking at the split of, well, is it battery versus hydrogen, and really seriously considering hydrogen as the long range alternative to a battery. Great idea. And I think that if he sees this through to the end, it's going to change a lot of the way we see the electrification versus hydrogen versus whatever kind of play out. We love to see both of them play out. Motors play well with either hydrogen or with battery. So we're happy to see anyone win. But Seth is doing some remarkable stuff.
Sweet. What advice do you have for someone not working in climate today who wants to do something to help?
I think that it's really just a matter of being willing to contribute resources. I think that, and then not resources being cash, but just opening up your network. I think that there's one of the best things that we have realized is when we talk to people, everyone seems to know someone that we should be in touch with. And folks who know friends or family or who just want to get in touch, making introductions to people who can make a difference, whether that is a customer, whether that is even someone at a national lab, whether that is an investor, it could really be anyone of impact. The climate startups that are out there today are doing a lot with a very small amount of resources, relatively speaking, to the broader startup landscape. And if people are able to come out and just say, hey, I can make this introduction, I can make even this small contribution to the success, it all waterfalls. You have no idea the compounding effect that something like that can have.
Awesome. Rory, that was really fun. I'm inspired by what you're doing, excited to watch your progress. Thanks a lot for your time.
Dylan, I appreciate it. Thank you again for having me on.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.